So here we are. We have y is equal to 4 plus cotangent of x minus 2 cosecant of x. We want the equation of the line at p, and p is pi over 2 comma 2. And if we put pi over 2 in for x, we had better get y is equal to 2. So if we put that in here for here and here, we had better get y is equal to 2. And I'm not going to confirm that. That's just a trig exercise. So part A is what's the equation of line at point P? Well, we have a point, pi over 2 comma 2, so we really just need a slope. And the slope is the derivative with respect to x of y. So let's take the derivative, and I wrote down some identities over here. Y prime is, well, derivative of 4 is 0. I'm not going to write that down. Plus cotangent of x. Well, what's the derivative of cotangent of x? It's negative cosecant squared of x. And we have minus 2 times, what's the derivative of the cosecant of x? Right, because we need to find the cosecant of x. It's right down here. And that's negative cosecant cotangent. And we want to find the derivative at the point, what x value? We want to find it at x equals pi over 2. So we put this in for x, negative cosecant squared of pi over 2 plus 2 cosecant x, not cosecant x, cosecant pi over 2 cotangent pi over 2. The cotangent of pi over 2, so I always like to put these angles up like this. If this were this angle were pi over 2, this would be 1, 0, this length would be 0, and this is 1. This is how I just remember cotangent. Cotangent is opposite over, adjacent over opposite, which is 0, so this is going to go to 0. The cosecant of pi over 2 is the inverse of the reciprocal of sine, so this is going to be 1, so this is equal to negative 1. So the derivative here is negative 1. It kind of makes sense from the picture also. So we have this slope, and now to take it into point slope form, we do y minus 2 times, or is it equal to the slope of negative 1 times x minus pi over 2. And in the back of the book they might rearrange this, but this is that's the answer. And remember, you want to make sure it makes sense. We'll look at the slope of the tangent line if you can see the plot. Okay, so what about this equation of the line at Q? Right now this is just a maximum, right? So that's where the derivative equals 0. So how am I going to do that one? Oh, I see. I should really look ahead. We want to know when y prime is equal to 0. Right, that's the slope of this. The slope of the tangent line will be 0 when we have a horizontal line right there. Right, so when is it a maximum? So y prime we just said is negative cosecant squared x, cosecant squared x, plus 2 cosecant x cotangent x. And from the only where I got this is right from this line right here, because we just took the derivative, and I'm just writing it this way. So we want to know when this is equal to 0. Well, just looking at it, you just say, I don't know, Mr. Steiner, how do we get this to be equal to 0? Well, the truth is we can factor this. Let's try to factor this and take out a negative cosecant of x. Okay, so what are we left with here? We're left with cosecant of x plus 2, I'm sorry, minus 2. Whoa. Minus 2 cotangent of x. Okay, well, let's look at this term by term and just multiply this back out. If you don't believe me, it's pretty straightforward. But can cosecant of x be 0 between 0, what are we looking at? We're between, somewhere between 0 and it looks like pi. I'm just looking at the axes, right? So this is from 0 to, this was pi over 2. well, just looking at the graph between 0 and pi over 2, is it possible for cosecant to equal 0? And this cannot equal 0 anywhere in there. You just look at the sine function. So we really want to know when this is equal to 0. So when is cosecant of x minus 2 cotangent of x, cotangent of x, when is this equal to 0? And I see I have about 4 minutes, so how am I going to figure this out? Well, let's go to our definition of sine and cosine. Maybe that'll help. Cosecant of x. So we're really looking for when is this equal to 0. Cosecant of x is 1 over sine of x minus 2, and cotangent is cosine of x over sine of x. When is that equal to 0? Oh, here we go. So sine of x is always going to be, it's never going to be 0. And so let's just see what happens when we multiply both sides here by sine of x. That was terrible bracketing, Mr. Steiner. Let's multiply both sides by sine of x. And then you can see right away that we have 1 minus 2 cosine x is equal to 0. So when is cosine of x, when is negative 2 cosine of x equal to negative 1? It's when cosine of x is equal to 1/2. Need a little bit more paper. And that is, I always have to draw my angles. When is this? 1. Okay, so when its cosine is adjacent 1 over 2, this is when this angle is 60. So this is x is equal to pi over 3. So we have our x value from this. If we take this x value here and put it in, let's go all the way up here. We put it in for x here, right? And then we would have our y value, and that would be the equation of the q, the line q, is whatever that y value is, right? Because its slope is 0. So I don't have enough time to do the cotangent of, well, maybe I do. If I get cut off, let's do the 4 plus cotangent of x minus 2 cosecant of x. So we want y. I think I can do it. Y is equal to 4 plus cotangent of pi over 3. What is it? Minus 2 cosecant of x. Minus 2 cosecant of x. I'm sorry, not x. Pi over 3. So let's draw our reference angle. Oh, we could just read it up here. 1 to root 3 cotangent is not, it's 1 over the square root of 3. 1 over root 3. Is that even on the screen? I don't know. Well, it's almost off the black. So cotangent of pi over 3 is, cotangent is opposite over adjacent. So this is 1 over the square root of 3 minus 2. Now we have cosecant of pi over 3. Well, good thing we still have this pi over 3 angle here. So cosecant is the inverse of, not the inverse, the reciprocal of sine. Opposite over hypotenuse, so 2 over square root of 3. Am I going to get this in time? 2 over the square root of 3. So we have 4 plus this minus 2, so we have 30 seconds. This is y minus equals 4 minus 1 over root 3. And let's do, that's 4 root 3. That's 4 root 3, man, root 3 minus 1 over square root of 3.